Okay, so in this video, I'm just going to add a couple of notes or comments with regard to doing the composites project. So again, on this one, I'm assuming you've gone through those tutorials that I've already assigned. So I'm not going to talk about how do you define plies, how do you take the plies and define a stack up based on it, and those issues that are discussed in the tutorials. But what I will talk about are a couple things that aren't discussed in the tutorials that I think we do need to do, and those are going to be again, assigning the material orientation and a couple of other things that link the composite properties to the model, and then lastly, how do we assign the maximum strain first ply failure model so we can see if we have failure in the plate. Okay, so here is my finite element model. So again, these are just shell elements. I've assigned the load boundary conditions here. You can see the tip loads and then the lateral stretching loads in the transverse in the y direction, and those all go in one collector. I've done those exactly the same as I've done previously. And again, remember, for a distributed load, you can put the force on here, which is the distributed load times the area of support. So you'll get uniformed on the uniformed elements, and then like half of that on the hanging elements, right? Like you see this force here is half of this because this only has half of an element support, whereas this one's supported under the full element, right? But we've talked about that before, and everything's the same. We created the mesh as shell elements, again, as we've done all before. The boundary conditions I applied here, the SPCs. At the middle node, I fixed all 6 degrees of freedom. And then on the other nodes, I released the Y degree of freedom so that it can slide. And so we see more of a uniform strain in the Y direction, okay? So that's what I would recommend doing. All right, so in this model here, if you go under the composites panel, I've already defined the material 8 for the composite. Where is that? Here's the material, right? And I've defined that using the mat 8, and I've used the elastic properties E1, E2, the major Poisson ratio, and G12. I also put the density in those, as we discussed in class. And then I also created the P-Comp P card, which, remember, that is the, normally if this was an aluminum plate, we'd use a P shell card, but the P-Comp P is like a P shell, but for using a composite material, okay? Okay. So let's talk a little bit about what we need to do next. So let me just kind of go over some of these slides. So the first thing we really should do is talk about element orientation. So when you make the mesh, all the elements might not have the same orientation. So in the tutorial, they showed you how to see the orientation, right? Remember, you can go under 2D composites, and you can look at the element normals, and you can also look at the orientation. What I don't think they show you is how you assign it. So if you go under material orientation, you can get the following window. And here what you're going to do is just pick all the elements, and then you can assign by vector in the X direction, in this case, the way I've aligned the model, which I've already done. But you hit project, and that'll do it. And in fact, now if you zoom in on here, you can see they're all aligned. That's the material orientation. So that's the X-axis. So that's fine. So that's that means that the ply labs will be relative to that, okay? The other thing that I've done in the composite is I defined a shape. So remember, shape is like if you have different regions where you have different layups. In this case, we have this one layup, so I made just a set of elements with all the elements. So you can see it down here. You can pick the element IDs. You know what I mean, right? So if you create a shape and then just select all the elements and you'll get it, right? So that's what I've done here. Okay. Now, if you look back to the model profile, under the components, we're using that laminate property here as the property for these shell elements instead of a P shell card, right? Okay. Here's just some basic notes. I probably should put this one here. So we're going to just talk about shell elements. We're going to use MAT8 for the material. P is like a P shell card, but we use that for composites. We're going to use the composite browser and hypermesh to define the plies and layup, just like you did in the tutorials. I won't go into that. And then really to do the first ply failure model, we're going to use a MAT-F card. So I'm going to talk about that. There is like a first ply failure thing. If you go into composites, we go back to composites, you can right click in here and you can create a first ply failure method. I never got that to work. So it probably does. I couldn't figure it out. I'm going to show you how I do it, okay? So it uses a MAT-F card, all right? All right, so we already talked about this. MAT8, I think we understand. We've talked about this in class. This is the orthotropic plane stress material stiffness. Here, this is the stresses, the in-plane stresses as a function of the in-plane strains. It's got this relationship. And if you look at the MAT8 card, it defines E1, E2, nu1, 2, and G1, 2. And that's all you really need. And so those here, they fill out the symmetric matrix. So you know how to do that. So if we go to the material card, you can see I've already done that. E1, E2, nu1, 2, and G1, 2. And the density, okay? Now let's talk about the lamina failure. So in this case, we're going to use a maximum strain lamina for failure criteria. So we talked about maximum stress in class. So this is very similar. It goes the same way, except instead of maximum stresses, we're going to do maximum strains. So if the strain in the fiber direction, E1, is greater than the compressive strain and less than the tensile strain in that direction, the allowable tensile and compressive strains in the one direction, you don't have failure in that mode. Also, same for the two direction and in shear as well. So if the absolute value of the shear stress, the in-plane shear stress, is less than the allowable shear, we have no failure. If any one of these things is violated, then you have failure. So if this one's violated, like let's say E2 is less than the allowable compressive E2 stress, then that means that we've got failure due to compression. I should actually probably put minus signs in front of these things. I'll fix that. The minus should be a minus sign there, okay? All right. And so the way we do that is going to be in a MAT-F card. So a MAT-F card looks like this. It's going to be a little hard to see. But basically, you can Google it, but it allows you to define a criteria. So this could be max stress, max strain, psi Hild, psi Wu, Hashin, whatever it is, okay? It allows for all those and some of the more modern ones, the LARC ones and all that sort of stuff, right? Basically, these are the parameters for that. So when you set criteria to be strain, it's going to use maximum strain, and then you set V1, V2, V3, V4, and V5 as given here. This would be for strain. V1 would be epsilon 1 in tension, V2 would be epsilon 2 in compression, V3 would be epsilon 2 in tension, and V4 would be epsilon 2 in compression, and V5 would be the shear. Okay? Now where we do that in hypermesh is if you go and click on the material model, right, the MAT8 card, and then down here, scroll down a little bit, you are going to see. So don't do it here. These don't really do anything. I couldn't get those to work. But if you go down here, you will see a MAT-F option. Click on that, and that will expose exactly those things, criteria and the 5V. So here I've already done it. So we're using strain. Right here, the other criteria you can use. So we're going to use strain. And then here are those strain values, okay? So V1, like I said, is the maximum tensile strain in the fiber direction. V2 is the maximum compressive strain in the fiber direction. It's transverse and shear. Okay, so once you do that, now those are the failure criteria for that, okay? And I believe now we're good. Now we're good at this point in time. I don't think you have to do the first ply failure model. Okay. So now we're basically ready to run this. So I think this should work. Let me just save this. Hopefully I didn't screw it up. It's always risky doing this, but anyway. I don't always do composite models, so I hope I don't mess it up. But we're going to just solve this using OptiStruct. Oh, I'm sorry. There's one more thing I should mention. Okay, before we solve it. If we look at the load step, to do this correctly, when we look at the load step, since we're doing maximum strain, we have to write out this two things. I should put that in the notes. I need to also do, make a new slide. Wait, what? Insert, make a new slide. Okay, so we need to do two output options. See failure. So this is going to be in the load step. Output, right? Like just like we've done this in the past to outload some of the things for the 1D elements. So see failure, and what that's going to do is that says write out okay? And so normally on that one, we're going to set NDiv equal to 2, and I think that's it. There might be something else. The other one we have to do is C strain. And this one is to write out the element strains. Okay, and again, we're going to use NDiv equals 2. So NDiv 2 is going to basically write it out at the top and bottom of each lamina, okay? So we need to set those two in the load step. So if you go into here, here's the load step. Again, we're under the model, and here's the load step. And if we scroll down to the output part, which we've done before, I think I've already done this. Yeah, you can see I have already, let me make this a little bit bigger so we can see it maybe. I've already checked C failure, or I check output so you can do output options. Then I checked C failure, and I set NDiv equal to 2. And then, well, options is all, I guess. And if we go down here, we've also written out the strain, again, NDiv to 2. Oh, and for extra, let's make sure we write out the mechanical strains, okay? Because the mechanical strains are the ones that produce failure, okay? So I should probably do this here as well. So type. No, is it type, or what is it called? It's not type, it's called extra. Okay, so for the extra option, we're going to use mech. So that's going to write out the mechanical strains, the measurable strains, the ones that are result in the stresses, okay? And so I've done that. Whoops. So now we're going to output all those things. All right? So you'll be able to see it. Let's save this, and now let's run. And hopefully I don't get some errors. All right, it completed. Hey, no problems there. So there it goes. It solved. Yay. Now let's look at the results. It'll hopefully load up Hyperview, and I'll show you the post-processing. I need the Jeopardy music now. Okay, there we go. Let's get it so it fits on the screen. So again, some of the tutorials use HyperWorks. You can use that as well. I don't mind. I'm just more used to using HyperMesh and HyperView. I do need to get more used to HyperWorks because I think we're transitioning to that actually. So, but let me still get this so it's on the screen. This is so jumpy when I do this. Okay, it's almost there. How's that look? Is that everything? Let's get it fully on the screen. Okay, that's good enough. So it loads up the model. We hit apply. That's all good. Oh, whatever. Okay, so I don't have to. It's already loaded. So you can see here we got this load step and all that good stuff. So you can look at the deformation, everything the same way. But if we want to look at the results, if you look under results, we have element stresses, so you can look at everything like we've done before, like von Mises, and there's the von Mises stress. You can look at the normal stress in the z direction, although it'll be 0 in this case. Let's do x, y. This would be the shear stresses projected, okay? But in particular, if we want to look at the failure, right, because again, we don't know what it is in each layer. In each ply is going to have different stress components because of its orientation. If we look at the failure component ones, right, now we can see what's going on here. So I can do failure index. That will show me the actual failure index itself. So what this means is if the index is 1, there's a strain condition where it's right at failure. If it's greater than 1, it's over failure. If it's less than 1, it's under failure. So in this case, I've got the maximum at about 0.8. So around here, and these guys are all around 0.5 and 0.6. So that's, we haven't failed, but we're getting close to it. So I've got a margin there of about 10, 20%, okay? You can also look at which ply is causing that failure. So if I change, instead of looking at the failure index, if we want to look at the plies with maximum failure and apply, here you can see this is actually integers. And so this denotes which ply is the one that's the one closest to failing. So for example, in this region here, it's going to be ply 7, the one just below the top ply that's closest to failure. Out here, it's going to be ply 1. That's the bottom ply, okay? And a little bit on this edge, it flips to the upper ply. And you can look at other things here as well. You can look at, I think this is going to show you the strain itself. So this is the strain, the limiting strain. You can also look at this if you want to look at the strains or the stresses. If you write out this, well, here are the stresses. If I do the composite stresses, I believe I can look at, so let's say we do normal X. Let's say we do normal X, okay? This is the maximum, but you can also go and change the layer to give you the values at the top and bottom of each ply. So this is at the bottom of ply 1, this is the stress in the X direction. At the top of ply 1, this is the stress in the X direction. So when I ask you to write out the stresses at one of the elements, the limiting element, you can go in here, pick the element, and it shows you the shaded value, and you can go back to here and cycle through like normal stress in the Y at the different plies and all that sort of stuff, okay? And you can see all those results. If you go right here, here, it's changed back to that, like we've talked about, okay? So I think that'll get you through it. So, a couple things just to review, right? I think the Mat 8 is covered in the tutorials. You should probably check that all your material orientations are going in the X direction. Under the Mat 8, you're going to want to use the Mat F option to do maximum strain failure criteria and the strain parameters in the lamina. Under the output steps for the load step, make sure you write out C failure and C strain. You can also do C stress. You might as well just do it, but I think it writes it out automatically. But you can do C stress as well. And in this case, we don't have a distinction between extra. You just do this, okay? And I think that's it. I think if you do that, you'll get the results, and it's really not too bad, okay? If you do have any issues, just let me know, okay?